In this video, we look at the WASSCE 2023, the Nigerian paper called Math or General Mathematics, question number 7, the objective question. And there is a circle theorem. We see a circle here, and it says that in the diagram, O is the center of the circle NST. So we have NST. So there is the circle NST, and O is the center here. And it says that the magnitude of the line NT equals the magnitude of the line ST. So that is the line NT and that is the line ST. So we see 2 bars on NT and 2 bars on ST. So that means they are of the same magnitude or length. And angle NTS is 36 degrees. So angle N from here and then TS. So this angle is 36 degrees NTS. Find the measure of the angle marked T. All right. So there's the angle marked T. The angle marked T is between a tangent. There is a tangent. The line RV is a tangent at S. Before we start, if today is your first time on my students class channel, don't forget to subscribe and click the notification button so that you'll be promptly informed anytime we upload a new video. And hey, one more thing. Click the like button so that the video can reach a lot of people. Thank you. Now let's continue. You see, a tangent is a line that is known to touch a circle, and the angle is between a tangent and a chord. So, there is a law that we can use here. Let me draw the circle so that you get what I'm saying. If you have a tangent to a circle and you have an angle formed between the tangent and a chord in a circle, then there is a theorem you can use to solve that. So I am going to draw only what I'm talking about here so that we can get it right. So there is a chord here, and this is N, and here is S. So from R, and this is V. Okay. So we have an angle here, and the angle T is here. This is the angle we've been asked to find. The angle T is here. Okay. So there is a circle theorem that says that the angle formed between a tangent okay, and a chord is equal to the angle in opposite segments, or you can see alternate segments. Okay, so that is what we see here. We see that when you draw this chord NS, it divides the circle into 2 segments. The bigger one here, we see it here, and we see one here. So if we continue this chord and we draw another chord here to form the triangle we see here, okay, that is the point T. The angle here is 36 degrees. So what we are saying is that the angle here T is equal to the angle in the opposite segment. If you really want to get it well, the best way is to draw a circle. You draw a circle, you draw the tangent, right? And then you try to see if you can draw 2 Z. This a Z, one facing this way, then you draw another Z, all right, like that. So the law says that the angle found here is equal to the angle found at the top here. In the same vein, the angle found at this end is equal to the angle here. So you can see that I can draw Z in this circle. Look at it here. I can do this. 1, Z has got 3 lines, 2. So that is where the tangent touches the circle, and the third one forms part of the tangent. So that is the first Z. I can draw the second one. They share the same head here, so the second one too have the same bar here, 1, but the 2 they will meet here, 2, and the third one also form something like that. So what we are saying is that the angle between this part of the tangent and the chord is equal to the angle in the opposite segment here. So if here is 36 and we can draw Z here, you see 1, 2, and it goes that way, 3, and we can draw another Z also here, 1, then it comes down here 2, then 3. So this means the angle here is equal to the angle here. So we don't even have to calculate this. Simply t equals 36 degrees, and that is A. Well, if you still don't understand, you can go the opposite way and you can use this one too. Well, I have to warn you, this one will be a little bit longer. So if you still want to go by this, you can also use it. Let me draw the diagram that we have there. So we have some lines coming this way, and we have another one from here meeting here. Okay, so it goes that way too. So here is V, here is S, we have R here, we have N here, we have M, and this comes down here. Okay, all right, I think this is cool. So you have something like that. So here is T, and that is the center. Let this go that way. We have one coming down here. We have O, that is 36 degrees. Okay, so the angle here is T degrees. All right, so if we want to solve it that way, I did say that the angle between the tangent and a chord is equal to the angle in the opposite segment. So by this, if we have something like this in here, then it means the angle here, if here is say T, or the angle here too is T. If here is say K, then the angle here too is K. Now another thing we have to realize there is that we are told that that is isosceles. The triangle here is isosceles, that is T and S. So that tells us that the angles here and there are equal. All right, so angle here and there are equal. So the sum of the interior angles of a triangle is 180 degrees. So if here is say X, then here too is X. So that means we can sum the angles in triangle T and S. So we have something like 36 degrees plus X equals 180. This will be a very long way, but I just want to prove to you what I just said. So you divide both sides by 2, then you have X to be 72. So what we have here is the whole of the angle here is 72, and there too is 72. So if here is 72 and here is T, and if here is 72, look at this here. The angle here is between a chord, the chord ST, and this tangent. So the angle between a chord and a tangent is equal to the angle in the opposite segment. So that means also here is 72. So we have 72, 72, and T. But the angle T and the 72 that we see here and the other 72 that we also see here, they are on a straight line, so they add up to 180 degrees. So T plus this plus that is 144 equals 180 degrees. And if we subtract 144 from both sides, we have this. Okay, so T will be equal to 36 degrees. So we still get 36. It's a very long way anyway, because this one was pretty simple. You can still solve it in another way. Let's still look at it here. So whichever way we go, we get the same thing. All right, so if we want to consider the angle here, look at this here. We know that here the triangle TNS is isosceles. Do we also know that triangle NSO is also isosceles? Of course it is also isosceles. Why? Because from O to N is a radius, O to S2 is a radius. So these sides, let me use red, these sides two are equal. All right, but do you know that the angle between a radius and a tangent is also 90 degrees, because this is called the normal. So that is 90. So if we can know the small angle here, then we can subtract it from 90 and get the angle T. But do we know the angle here? Of course we do. One of the circle theorem says that the angle, when two angles are subtended by the same chord, so we see this here, we see chord NS. Okay, this chord here, this chord forms an angle on the circumference at T. It is 36. So the moment you draw this chord, it divides the circle into two segments. That is the smaller one, and we have the other one here. So when two angles are subtended by the same chord in the same segment, but one ends at the center, so from this chord to the center, and one goes to the circumference here, the one at the center is twice the one on the circumference. So if here is 36, then the angle at the center is times 2, and that is 72. So here is 72 degrees. And if here is 72 degrees, triangle NSO, this triangle is isosceles because these are equal. So this implies that the sum of the interior angles of a triangle is 180. So if we say here is y, then here too will be y. So that means y plus 72 also gives 180. So we have 2y to be equal to, let us subtract 72 from both sides. So we have this. So 2y equals, so we have 108 here, and we divide both sides by 2. 2 here, 1, 2 here, 1, 2 here. Angle T will be equal to 90 minus 50. What did I get here? Sorry, 54. So T equals, when we subtract 54 from 90, what do we get? We get 36 degrees. So we still come back to the angle 36. So the first one was the most easiest to find T.